Good afternoon. Welcome to a late start, but another afternoon of Chem 170 with your host, me, Dr. White. And I hope you all had a good President's Day. I better drink some tea. And let's get started. All right. As you know, I think it was last Friday or Saturday morning at the latest, I sent out I posted your test number 1 scores, and I also posted or sent out an individual email for each of you, which had your score points for each answer on test number 1. What I like to do today is I'm going to be going through now test number 1, and I will go through the answers. Remember, if you have any questions, ask. Also check, just make sure that I didn't make a mistake. If I made a mistake, let me know and I'll correct it. Now, one of the tough things is in organic chemistry, it's very hard to give partial credit. However, on nomenclature, if the base name is wrong, you get 0 points, even if you have the alkyl groups right. You first have to have the base name. All right. What I'd like to do now is go through test number 1. If I made a mistake, email me and I will check your test again and correct it. I've posted the scores in D2L, and you also got an individual email with how many points you received for each answer on test number 1. Now, listen carefully. Because I dropped the lowest test of the 4 tests you'll have, no matter what you did on this test, every student at this point still has the opportunity to get an A in my class. Again, because I dropped the lowest test, if you didn't do good on test number 1, you still have a very good opportunity to do well. But you need to see me. And those who had problems, I wrote a note about seeing me so I can help you. Now, what kind of grade are you getting right now in my class? Well, look at the syllabus. If you got 90 and above, you're getting an A, 80 to 89, B, 70, 79, C, 60, 69, D, below 60, F. Now, again, everyone still has a chance to get an A. But if you got a low score, you have to do something to turn around. Now, I can share with you this, and that is, if my memory serves me correct, and I apologize for the late start, I think 60% of the class earned A's, 90 and above, which tells me I didn't write an impossible test. And if I think the highest score was 104, and I think 3 or 4 people got 100 or higher. And that really tells me I didn't write an impossible test. All right, any questions about test number 1? And by now you also know what I mean by practice problems. And my problems that I give you that I call practice problems are designed to help you do good on my test. And always remember, if you have any problems or want to know how to do better or need any help, come to my office hours, or if you can't make it, then contact me and I'll see if I can arrange to meet you on Zoom at another time. All right, any questions? Oh, again, I'll cut out from the video this because I just don't want the answer key floating around on YouTube forever and ever. That's just a habit of mine. All right. Now, I think I mentioned it last week, but I'm going to change it mainly because of the late start. And also I was going to change it. We didn't have a late start. While I'm talking to you, I'm going to open up something. And that is on Monday, we'll go through the alcohol problem set. And then next Wednesday, because we finished it already, we'll go through the ether and epoxide problem set. Again, next Monday, we'll go through the alcohol problem set. And then the following Wednesday, we'll go through the ether and epoxide problem set. So you know what that means? It's new chapter time, new functional group time. Hey, I have to warn you about something. This new chapter, if it looks like I'm having a lot of fun, I am, because it contains two of my favorite functional groups in all of organic chemistry. How many of you, what would I say? How many of you have a comfort food? If you get really, if you're anxious or don't feel good or something like that, you want to pick me up, you eat something. And my comfort food, I should tell you, one of my favorite ones are either Doritos or Lay's onion and sour cream potato chips. Oh, those are dangerous. But now you're going to find out Dr. White is really an organic chemist. I have comfort functional groups. If I'm not feeling good, I think about these and it always makes me feel better. And what are those comfort functional groups? They are aldehydes and ketones. And does everybody see Aldehydes and Ketones, Chapter 9 on your screen? Thumbs up, people. Thank you, Vivian. All right, and thank you, David. All right, now, one of the new functional groups is called an aldehyde. And an aldehyde has carbons attached to a carbon double bonded to oxygen, and it also has a hydrogen. So an aldehyde is this. Now, there are other ways of drawing aldehydes. You could draw it without showing the carbon double bonded every bend in a line, or you could show it like this. I like writing it like this because I think it's the coolest way to do it. But then again, I'm an organic chemist, and you can do it either way. And this is an aldehyde. Now, we also have a ketone. And a ketone is a functional group with a carbon double bond to oxygen, and it's attached to not one, but two R groups. R means carbon and hydrogens. Now, if you notice, I have here, this is called a prime. And all that tells you, like X and Y in math, R and R prime can be different or the same. If I just had two of the same R groups, R and R, that meant they'd always have to be the same, and that's not true. And we can also draw it like this. So we have a ketone and aldehyde. Aldehyde, carbon double bond to oxygen that has an R group and a hydrogen. And a ketone has R and R prime again attached to a carbon double bonded to oxygen. Now, later in this chapter, some of the chemistry, a lot of it, of aldehydes and ketones are the same. And organic chemists are lazy. And to show that, you can write it like this, or another way I write it And when R prime is a hydrogen, that's an aldehyde. When R prime is carbons, it's a ketone. And notice I say R prime can be arrow, which means carbon, hydrogen, or it could be a benzene ring even, or double bonds. Now, one of the reasons I love Carbonyl Group or ketones and aldehydes is my PhD thesis dealt with ketones and aldehydes. That helped me get a PhD, which is one of my great accomplishments in life. And it also, my knowledge of aldehydes and ketones helped me get my first US patent. And it also helped me get my last US patent that I got. And therefore, I love aldehydes and ketones. Really, I do. Now, when you look at a aldehyde or ketone, they have something in common. That's carbon double bonded to oxygen. And that's so important in organic chemistry. It has a name. It's called the carbonyl group. And the carbonyl group is a carbon double bond to oxygen atom, which I have shown here in red. And this, I think, personally, for me, is one of the most important things in all of organic chemistry. Now, the carbonyl group is not a functional group, but is found in a number of important functional groups, such as in aldehydes and ketones. Again, the carbonyl group is not a functional group, but is found in other functional groups, such as, or in functional groups, such as aldehydes and ketones. And there are a couple other I'll talk about this semester that have a carbonyl group. And as I say here, those call the group, the carbonyl group is not a functional group. It's the carbonyl group is found in many key functional groups, such as aldehydes and ketones. Since it's such, for me personally, and for a lot of organic chemists, such an important aspect of organic chemistry, you should know, hint, you should know how to describe and draw a carbonyl group. How do you do that? You name it. The carbonyl group is, this is how you draw it. And if you draw an aldehyde or ketone, I give you credit too. And it's described as the carbonyl group is carbon, or you could have also put carbon atom, double bonded to oxygen atom. So I better be subtle on this Wednesday. You should know how to describe with words and how to draw a carbonyl group. And again, a carbonyl group is carbon group. A carbonyl group is double bond to an oxygen atom. And that's how you describe it. What is a carbonyl group? Carbon double bond to oxygen. And here's how you draw it. Now, how do you name aldehydes and ketones? And I think because of my late start, let's go until about 2:30, and we'll take a 5-minute break then. I think that way we'll try and get back on track. All right, let's look at an aldehyde. How do you name that? Well, let's draw an aldehyde first. Now, one thing I should mention, because I learned it this way, and good habits I don't break, I always put my carbonyl for an aldehyde on the right of a molecule. You could put it on the left, but I do it on the right. All right, let's take a look at this molecule. And the question is, what functional group is in it? Look for something different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And if we look at this molecule, we have an oxygen that's double bond to carbon. And on that carbon that's called the carbonyl carbon, we have a hydrogen and we have carbons, our group. And this is an aldehyde. I should mention the carbon double bond to oxygen in a carbonyl group is called the carbonyl carbon. I'll never ask that on a test, but I'll use that terminology a lot. So we have an aldehyde. What do? Find the longest carbon chain, which includes the aldehyde. Another way of saying that, which includes the carbonyl carbon. Name that chain as per the IUPAC rules for alkane. Then at the end of the name, alkane, like propane, butane, or whatever, you replace the E at the end of ANE with AL. Again, find the longest chain that contains the carbonyl carbon, the carbon of the aldehyde, that's double bond to oxygen, name it as an alkane, drop the E at the end, replace it with AL. Now, carbonyl carbons rock, and an aldehyde, that's always number one, always. And therefore, you don't have to put that down because everybody knows it's always number one, always. And then name a number of the other substituents as per the IUPAC rules you've already learned. So let's go back and look at this one. Here we have this molecule, 1, 2, 3, 4, 5. That's pentane. It's an aldehyde, drop the E, add Al, and it's pentanal. You don't put the number 1 down there because everybody knows that. Ooh, let's try another one. And sometimes I'll draw my carbonyl like this, or sometimes I'll draw it like this. And organic chemists do that. It's the same molecule. And let me make a quick change now that I'm thinking about it. And the question is, how do you name this? I'll do this one, then I'm going to let you have one to try. And what's the longest chain? 1, 2, 3, 4, or down to here would be 4. So the longest chain is 4, because we have an aldehyde. Remember, look for what's different. Carbon double bond to oxygen. And longest chain 4 is butane. It's an aldehyde. Drop the E, add Al. Remember, aldehyde has this general function of carbon double bond to oxygen with a hydrogen R group on it. So butanal. And as soon as you say that, that's spoken for. Oh, we've got something left over. And it's your old friend, the methyl group. And what carbon is it? Carbonyl carbon is always 1, 2, 3. It's on carbon 3. So we have 3-methyl butanol. Now, interesting, because of the way a aldehyde is, you can't have an aldehyde in a ring. You can't have ketones, and I'll show you that later today. And now it's your turn. What would be the IUPAC name of this molecule? 3 points each. I think I sent out the poll a little early. Let me relaunch it. All right, I think everybody's done. Let's take a look at this. What's different? What's not a carbon-carbon single bond or carbon or hydrogen? Ooh, oxygen double bond to carbon, carbonyl. It's got a hydrogen and carbon's R group. What's the longest chain? Well, I don't know. Remember, it has to include the carbon bonded to the oxygen, carbonyl carbon. 1, 2, 3, 4, 5, 6. If we went down here, this would be 3, this would be 4. So what's longest, 6 or 4? Hopefully you all pick 6. 6 is hexane. By the way, this is an aldehyde, as I have pictured here. And therefore, that's hexane. It's an aldehyde, drop the E at the end of hexane, add Al, the carbonyl carbon, this one right here, carbon double bonded oxygen is 1. And notice on carbon 2, we have an ethyl group. And that's 2-ethyl hexanal. Everybody say hello to my old friend, 2-ethyl hexanal. And because I knew special properties of this aldehyde, that allowed me to make things that nobody else ever could. And that allowed me to get my first United States patent and invent a new molecule too, actually. One that wasn't a patent and one I did use this to make that isn't a patent. That was my first big discovery in the chemical industry. Oh, let's do one more. These are fun. Oh, is that a pretty molecule? All right, give the IUPAC name for that molecule. All right, hopefully you're all done. What do? Look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And hopefully you all saw, oh, look, an oxygen, and it's double bond to carbon. And the carbon right here, there's a hydrogen, and then their carbons are. This is an aldehyde. And what's the longest chain that has the carbonyl carbon, the carbon double bond to oxygen? And the answer is 1. That's always going to be 1, 2, 3, or up here it's 3, or down to here it's 3, excuse me. And that's propane, is the alkane with 3 carbons. It's an aldehyde, drop the E, add Al. And then what do we have left over? Oh, not 1, but 2 methyl groups, dimethyl. And even when they're on the same carbon, you see di, you need 2 numbers, and that would be 2,2-dimethyl propanol. That's a pretty aldehyde. Never used that one, but it's pretty. All right, now, in nomenclature, there are 2 skills you should have. One is, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. And let's look at an example of that. Again, this would be and let's do butanol. I'll do this, and you know I'm going to share the fun. So how do you decode this to know what to draw? You start from the right and move left. Al ending says aldehyde. And it has that structure. Now, if that were an E, butane, 4 carbons. And at the end carbon, aldehyde. I know there are 4 bonds to carbon, so I can put in the rest of my hydrogens. Now, I'm always going to write an aldehyde on the right. If on a test you were to do this, I've got to force myself to do this because it's not what I normally do. Both of these are correct. And they're the same molecule. All you've done is rotate it like I'm doing my hand 180 degrees. But this is the way I like to do it. Either way is correct on the test. And let me give you one to do. Draw the structure for octanol. Now, one thing I neglected to mention when you were writing the IUPAC name, alcohols have an OL ending, aldehydes have an AL ending. Make sure on test number 2 and the final, you make sure your O and L are something I can discern. Because if I have to guess, is that an O or is that an A? I can be wrong 50% of the time because I'm guessing. You never want me guessing when I'm grading a test. I don't want to have to guess. So make sure you write your O or L when you're doing nomenclature for alcohols or aldehydes correctly. All right, how do you draw the structure? Go from the right and move left. AL ending tells you you have an aldehyde. And if that were an E, octane is 8 carbons. And at the end, 2, 4, 6, 8. I got it right. And each carbon should have 4 bonds to it. So don't forget to put in the hydrogens. And remember, the carbonyl carbon has 2 bonds from the oxygen, a bond from the R group, and 4 minus 3 is 1, which is why it also has a hydrogen. Oh, let's do one more. These are fun. And this one's for you to do. Draw the structure for 3T, or as you know, TERT, but organic chemists never write down TERT. We're lazy. 3T butyl, known in L. Your turn. And it must be, turn off your webcam Wednesday. Should I do that too? Nah, I'll leave it on. All right, I think everybody's done. Let's take a look at this. How do you know what to write? Draw the structure. Well, you decode this by starting from the right, moving left, AL ending. And that's an aldehyde. If that were an E, no name, 9 carbons. The N carbon is my aldehyde functional group, carbon double bond to oxygen. It has a hydrogen. That's carbon 1. This is 2. This is 3. As I move forward this way, I have a T-butyl group. And I know there are 4 bonds to carbon. And I'm done. And that's how you do aldehydes. All right, let's move on. Let's look at ketones. And ketones are similar, not the same, but similar how you name aldehydes. You find the longest chain, which includes the ketone carbonyl carbon. Now, unlike aldehydes, ketones can be in a ring. So name that chain, or if it's a ring, as an alkane or cycloalkane. And here we drop the name it as an alkane or cycloalkane, and the E at the end, you drop that, replace it with ONE. For whatever reason, I never use the term to replace it with one. I always say ONE. And note the carbonyl carbon, a number in front of the main alkane name is given, and it always has priority, meaning the lowest number. So I'll show you that in a little while. Let's do one example, and then we'll take a break. Now, one way I could draw this molecule is this way, or I could have also drawn it this way. And I do both, depending on my mood and also what I'm trying to illustrate. What's different? Oxygen, double bond to carbon, carbonyl. We have two R groups. I call one of them R, the other R prime. It's a ketone. And let me finish this and we'll take our break. And what's the longest chain? 1, 2, 3, 4. It's a ketone. Name that as butane. Drop the E, add ONE. And then what carbon is it? If I start from this end, it's on carbon 2. If I start this end, it would be 3. So use the lowest number, and that's 2-butanone. And if I look, I went a whole minute over. Actually, I'm late, and I apologize again for our late start. Let's take a 5-minute break, come back at 2:36, and I'm gonna get up and stretch. Again, I'm sorry for the late start. I'll see you in 5 minutes. Let's take a break. Don't forget, we'll be doing our lab today also. Let's get going again. Welcome back to, oh, do I feel embarrassed? Late start today, Dr. White. We're talking about how to name aldehydes and ketones, and we're doing ketones now. Now, ketones, when they're acyclic, not in a ring, you need a number. And let me do another example. And here we have an example. And the question is, give the IUPAC name for the following. And how do we do that? Look at a molecule and see what's different. That's a fancy way, or simple way of saying, what functional group are we dealing with? And look for what's different. Now, let me fix up this double bond. And look for what's not carbon, what's not hydrogen. Whoa, an oxygen double bond to carbon. It's got carbons here and here, and they can be the same or different. This is a ketone. And what's the longest chain with the carbonyl carbon double bond to oxygen? Don't know. 1, 2, 3, 4, 5, 6, 7. Or if I came down here, it would be 7. So the longest chain is 7, and an alkane, that's heptane. It's a ketone. Ketones have an A-N-E ending, O-N-E ending, sorry, and drop the E at O-N-E. And then what is the carbon that has the carbonyl carbon that always has priority, lowest number? You wouldn't start from this end 1, because that would give it 6, which is smaller. 1, 2, or 6. Hopefully I'll pick 2. So that's 2-heptanone. And then we have a methyl group, and that's on carbon 6. So this would be 6-methyl 2-heptanone. Now I have to also show you for rings, and then I'm going to let you try some on your own so you can have fun too. And let's look at it, the following. And if we look at that molecule, we have a ring. And what's different? Oxygen double bond to this carbon. If we look at these carbons here, I'll call them R and R prime. Now in a ring, R and R prime are connected together. Now, what's the longest chain? No, what's the ring? 6 carbons. Remember, that's cyclohexane. It's a ketone, which has an O-N-E ending. Drop the E, add O-N-E, because the carbonyl carbon rocks, and IUPAC knew that. The carbonyl carbon in a cyclic ketone is always number 1. Because we know that, you don't have to put a number 1 there. So that's cyclohexanone. And Dr. White, Mother Nature, loves cyclic ketones. Later in the semester, I'll teach you your hormones. A lot of them contain a cyclic ketone. And I think you all know what the steroids, otherwise known as your hormones, are. If not, I'll teach you about that later in the semester. Now, since that's always number 1, what would be the IUPAC name for this molecule? Well, what's different? Carbonyl, carbon double bond to oxygen. Look for the oxygen's double bond to carbon. And it's in a ring. This is a ketone. And it also has an alkyl group on it. Remember, the carbonyl carbon on a ring is always 1. How many carbons that ring? 5. Don't forget the cyclo. It's a ketone, which has an ONE ending. Drop the E, add ONE, cyclopentanone. And on carbon 3, there's an N-propyl group. So it'd be 3N-propyl cyclopentanone. All right, your turn to have some fun. And what would be the name of this molecule, the IUPAC name? 3 points each. Your turn. Remember, look for what's different. All right, I think everybody's done. What's different? Oh, look, oxygen double bond to carbon and has carbons on both sides, R and R prime. They can be the same or different. And this is a ketone. How many carbons along this chain with the carbonyl carbon? The carbon double bond to oxygen. Don't know. 1, 2, 3, 4, 5. That was an alkane, pentane. Drop the E. Ketones have a ONE ending. Getting ahead of myself. Pentanone. Dr. White loves cycloketones. I'm always thinking about it. Just did this there. All right. Now, since it's an alkane, or acyclic ketone, not in a ring, you need a number. And the carbonyl carbon gets the lowest number, so that would be 2-pentanone. You started from this side, 1, 2, 3, 4. Which is the lower number, 2 or 4? And hopefully I'll pick 2. Oh, let's do another one. These are fun. And let me hang on. When I'm drawing stuff, remember the 20-second rule. Give me a little time in case I decide to change my mind. All right, give the IUPAC name for that molecule. 3 points each. All right, I think everybody's done, so I better get to work. And how do you name this? You look for what's different, what's not carbon, what's not hydrogen. Just get your attention like that. And hopefully it did. Oh, I've got an oxygen. And it's double bond to carbon with carbons here and here. And what is that? It's a ketone. Now you find the longest chain that contains the carbonyl carbon, carbon double bond to oxygen, 1, 2, 3, 4. If I do this 5, 6, or 4, 5, 6, 7, 8. And I hope we all agree 8 is greater than 6. What do we call the alkane? 8 carbons, octane. But it's a ketone. Ketones have a ONE ending. Drop the E, add ONE. Now, since it's a acyclic, not in a ring ketone, what carbon is the lowest carbon number for the carbonyl carbon? 2. So it's 2-octanone. And as soon as I say that, that's all spoken for. Am I done? No. We have an isopropyl group. And what carbon is, if this is 2, that's on carbon 4, says 4-isopropyl 2-octanone. And why don't you try this one? Give the IUPAC name for that molecule. Now, Dr. White's very happy because I love cyclic ketones. All right, looks like everybody's done, so I better get to work. What do we have that's different? What's not carbon or hydrogen? Ooh, an oxygen double bond to carbon in a ring. And notice I have carbons here and here. This is a ketone, but it's a ring. R and R prime are connect together, and it's a ketone. And remember, ketone is not spelled with a Y. And here we have it in a ring. How many carbons in a ring? 5. That's cyclopentane. Drop the E. Remember, ketone has an ONE ending. This is always carbon number 1, carbonyl carbon, and we're done. Oh, let's do one more. Ooh, that's a pretty molecule. Give the IUPAC name for the following. All right, I think everybody's done. Let's do this. What's different? What's not carbon? What's not? Ooh, oxygen double bond to a carbon in a ring. And that's a cycloketone. And in this case, R and R prime are bond together. How many carbons in the ring? 6. That's, if I can write it, cyclohexane. But since it's a ketone, you drop the E and use ONE ending, cyclohexanone. And now, are we done? No, there's a methyl group and N-propyl. Carbonyl carbon is always 1. You go clockwise or counterclockwise to give the alkyl groups the lowest number. So this would be 2, 3, 4. And we have 2-methyl, 3 N-propyl, cyclohexanone. And that's how you do it. Well, in nomenclature, there are 2 different types of questions, and it'll be on test 2 for this material. Give the IUPAC name for the following, and the other is draw the following structure. And Vivian, you have a question? I got my speaker on. Go for it.
Yes, is that 3 N-propyl or 4 N-propyl?
I made a mistake. Thank you.
Thank you.
Oh, no, I'm going home. Wait, I am home. I can't stop yet. All right, thank you very much. And I said on the first day, I do make mistakes. I was looking at the 3, it should be 4. Oh, am I embarrassed? I started late, made a mistake. I'm not going to have class tomorrow. Oh, we don't have class tomorrow. All right, so there are 2 types of nomenclature questions. And the other is, here's the name, draw the structure. And how do you do that? You start from the right and move left. ONE ending, I'll do this one, tells you have a ketone. And if that were an E, hexane, 6 carbons. Now, I'm always going to start from the right here. This is 1, this is 2. That 2 tells you my carbonyl is on carbon 2, and carbon 3, I have a methyl group. And there are 4 bonds to carbon. And that's what you have. I don't know why my 3 fell down, but that's how you do it. Now it's your turn. And why don't you draw the structure for 5-ethyl 3-decanone? And remember, I try and give everybody time to finish. So if you finish early, please be patient. And I think everybody's done. So how do we know what to draw? You start from the right, move left. ONE ending, ketone. If this were an E, decane, 10 carbons. And I'm going to call this carbon 1, 2, 3, and that's where my carbonyl is, carbon double bond oxygen. Then as I go further on carbon 5, 4, 5, I have an ethyl group, and now I get to put in my hydrogens because I know there's 4 bonds to carbon. And that's how you do it. Remember, ONE ending is a ketone. Let's do one more. And that's 3-isopropyl cyclohexanone. Draw that structure. And it looks like everybody's done, so I better get to work. How do you decode this? Know what to draw. You start from the right and move left. ONE ending tells you you have a ketone. If that were an E cyclohexane, it's a cyclic ketone. It doesn't matter which carbon you put the carbonyl, carbon double bond oxygen, most of you are going to put it on top. Let me draw my ring a little better. Whoops. And on a whiteboard, I'll have a bad drawing. And on carbon 3, we have an isopropyl. Carbonyl carbon is always 1, 2, 3. Isopropyl, 3 carbons. And there we have 3-isopropyl cyclohexanone. Now, this will not be on a test, but I can't go any further without introducing it to a very old friend of mine. And you don't have to copy this down. This is a ketone in a specialized, it's called a bicyclooctanone or octane ring. And this is bicyclo 222-octanone. And I did my PhD thesis on making that type of ketones. actually more complex than that, but that was an important part. Boy, say hello to an old friend of mine, very old friend. All right, let's move on. Now, as we did with alcohols, and we'll be doing the rest of the semester, there are common names that are used instead of IUPAC. And I'd like you to learn two common names for aldehydes and ketones. The first one is formaldehyde. And on a test, I'll never ask what's the common name in test number 2, but I can give you the structure or name and ask you to draw the structure. And for formaldehyde, this is one way you can draw it, which I normally do. Turns out for aldehydes, can be a hydrogen. And this is called formaldehyde. No one ever uses the IUPAC name called methanol. It's called formaldehyde. Now, the second one I would like you to learn is the simplest ketone, acetone. Now, I could write it this way, or I could draw it this way. Both are the same thing. Everybody calls this acetone. Nobody calls that 2-propanone. Nobody calls it that. And it took me a while to think about that. Now, you should know acetone is one of the 2 molecules used for nail polish remover. And it was, if you go to a big box store like Walmart or Target, or as my friend calls it, the French store, Target. But anyways, bad joke Wednesday, but he likes to say that. Up to a couple of years ago, if you went and saw a wall of nail polish remover and picked it up, most of the bottles would be acetone with a little fragrance perfume added to make it smell good. And a couple of years ago, now it's in the minority. Why? How many of you, and I don't, as you can tell, I don't polish my nails. How many of you are familiar with the nail polish that you put under a light, blue, ultraviolet light, to harden, or as we call it, cure? And that, as my students told me a couple of years ago, that is a much more durable, harder nail polish nail polish. And acetone doesn't do a good job on that. And in about, I think it's next chapter, I'll teach you the other molecule that does do a good job. But anyways, acetone, nail polish remover, and this is a structure for acetone. It's the simplest ketone. Nobody ever calls it 2-propanone. Now, there's something important I need to talk about right now. This will not be on the test. First of all, because the one company I worked at, which was the largest manufacturer of formaldehyde in the world, especially in the United States too, and that was at that time was called Borden Chemical, and now it's called Hexion. And because of that, I'm a world authority in formaldehyde. Now, after I left that company, I was a consultant, I still am, and I also teach. And I had heard about this problem. And it was that certain trailers were getting people very sick. Now, how many of you remember or heard about Hurricane Katrina? And Hurricane Katrina, I forgot what year, let me look it up real quick. And that was in 2005. And a number of people, 1,800 people were killed. And around the city of New Orleans and that whole Gulf area, it did tremendous amount of damage, tremendous amount, and destroyed a lot of people's homes, apartments, or condos. And because of that, the government, and that was under President Bush, the second Bush, and they had an idiot in charge of FEMA, excuse my language, but he was. His former only experience was running a horse contest, but anyways, they messed up. And in order to get people housed, they went to different trailer companies and commissioned them to build a lot of trailers. And after a while, people were getting sick living in those, they're called Katrina trailers. And there was a very brave woman, Becky Gillette, who at that time was a volunteer for the Sierra Club. I never asked Becky, one of these days I got to email her and ask her, how did she determine to look at formaldehyde? And she had a company tester, and I'll tell you the name of that company, to test those trailers. And they found out there was high level, what we call free formaldehyde in those trailers. And formaldehyde is a very dangerous chemical and hazardous chemical. And when I heard about that in the news, was she had found that, and she was actually fighting President Bush, who was, and FEMA, and also for a while the EPA, to get people to know about that was the problem. They were saying, oh, there's no problem. I can't find it right now. But anyways, when I heard about that, I was able to track down her phone number, called her and said, I'm an expert in formaldehyde and its uses. My last patent used formaldehyde. If you need my help, I'll do anything I can help you with in this situation for free. And I did help her. I don't think I was the only person helping her on this. And one of the things she asked me to do, because my credentials, my knowledge of formaldehyde, after Bush term ended and he was replaced by President Obama, I sent a letter to President Obama and also the head of the EPA requesting new laws, and they're called the CARB laws, because California already had enacted this, knowing the dangers of formaldehyde, and CARB stands for California Air and Resource Board, to adopt these laws, and they were, and people are safer now. Now, because of that, number of things, one thing I want to show you real quick. You should see on your screen toxic trailers. And this is toxictrailers.org. There's a picture of Becky Gillette. And I haven't talked to her in a couple of years. It's been a while. And if you scroll down, first of all, there are horror stories here. If you scroll down on the right, you see tests for formaldehyde. And this kit can be purchased from this company called located at www.acsbadge.com. And it's $39 a kit, at least then. I don't know if it's changed any, because I don't know when's the last time she upgraded this. But this is the company that President Bush and FEMA, head of FEMA, tried to discredit and prove their results were wrong. When the EPA tested what they had tested, they found out that company was correct. And it's very reputable. And why am I telling you this? From the horror stories I heard from people I talked to through Becky Gillette, if you've ever gotten any wood products that's not solid wood, and it came from China, even to this day with the CARB laws, you're not 100% sure is formaldehyde free. And one of the things Becky asked me to do while that was happening was then Congressman Waxman, his select committee of Congress was going to have a hearing on these Katrina trailers on TV. And I found out, unfortunately, it was just for show to PYA protect your back ends. And she asked me, could you call this person? He's the lead investigator for the Select Committee of Congress reporting to Waxman, Congressman Waxman. So I called him and told him all about the dangers of formaldehyde and everything. And he thanked me. And I said, could you do a favor for me? And he said, what? I said, the hearing he's going to have on TV, Congressman Waxman, they were going to bring all the owners of the trailer companies, most of them were located and are still located in Indiana, before the committee, and it will be televised. I asked, could you ask one question? He said, what's the question? I said, could you ask him to ask those company presidents where they get the plywood to make the trailers? Now, why is that? Because I work for a company that made, it's called a resin, you know it as the name glue, that holds piece of wood, either particle board, particle strands, or sheets of wood called plywood together to make those compounds. And if you don't do it correctly, making that glue, it has free formaldehyde in it, formaldehyde that comes off from the plywood. And because of OSHA in the United States, workers are limited to the exposure of formaldehyde. Well, this keeps the formaldehyde level low. Guess what? They don't have those laws in China back then, even now. And it costs more money to keep that level low. So as soon as I asked that question, the person I talked to said, I can't ask him to ask that question. Immediately I knew they knew where that formaldehyde came from. Why? Because with the hurricane, there was a severe shortage of plywood in the United States. And those companies went to China, I bet on it, and got wood that was high in formaldehyde. And that's how those people got sick. Now, the reason I'm telling you this is if you know anybody who's got remodeled kitchens, and if their wood is not solid cabinets, which most aren't, there's a veneer of different veneers that make it look like solid wood, but underneath it's plywood. And if those came from China, it could be high in formaldehyde, even with the carb laws today. People try and sneak that in, and it happened a couple of years ago. Or if you know anybody who's got a new baby and they went out and bought new furniture for their baby's room, and if it's not solid wood, which most isn't, have them check. I have had students who've used those, and luckily they haven't found any formaldehyde, but they feel safer now. And that won't be on a test. All right, let's get back to aldehydes and ketones. All right, this will not be on a test, but where do we find aldehydes and ketones in nature? Benzaldehyde is one. And that has, I forgot. I should have mentioned this in nomenclature of aldehydes. This is benzaldehyde, which you should know. That's both the IUPAC and the common name. And you should know the structure of that. I do that once in a while, I forget. This slide reminds me to teach you that. That's when R is a benzene ring. And this is responsible for the odor and taste of cherries, and also it's in almonds. Now, cinnamaldehyde, also trans-cinnamaldehyde, I believe that's the structure. Let me look it up. Sometimes I'll get that wrong. Somebody have a question? Or did I lose you? Have I been sharing? Nope, I'm sharing. Got their mic on, turn it off. And I did get it wrong. Sorry about that. I knew I didn't look right. And this I'll never ask on a test. And vanillin you learned about in the last lab, and that's also aromatic. It's an aldehyde, and raspberry ketone is a ketone. Let's take a look at this real quick. And here's the molecule right here. For raspberry ketone. I'll never ask that on a test, these names, but that's responsible for the taste of raspberries. And Dr. White loves raspberries. I also like blueberries too. All right, let's go through this real quick. Then we're going to do a lab. I apologize. I'm not going to take a second break because I started late again. I apologize for that. That's the second time in the last 10 years that's happened. Well, hopefully that's the last time for a long time. All right. How do you make aldehydes and ketones? Now, this reaction we've already covered. If you take a primary alcohol, oxidize it, you get an aldehyde. Again, we've covered this in alcohols, so I'm just going to ask you to do one example. So if you take a primary alcohol, oxidize it, you get an aldehyde. And we went through these in the alcohol chapter, but let's do one more. And I'll let you try this one. What structure would you get? What compound? What would be the product of the reaction of that molecule with and that reaction? Remember, O bracket O means oxidizing agent. All right, I think everybody's done. What's different? What's not carbon or hydrogen? Carbon, single bond. Ooh, oxygen, a hydrogen, and a carbon with carbons here. that's a primary alcohol. And if you oxidize it, use the hydrogen there, one from there, and you form a carbon-oxygen double bond, and you have an aldehyde. Do you break carbon-carbon single bonds? No. And here's our R group. Here's this carbon here, which becomes, now you know, the carbonyl carbon. And therefore, we have 3 carbons. This N carbon here becomes the carbonyl. And that's how you get an aldehyde. And at this point, I'm going to stop and we're going to do the lab. Again, I apologize for not taking the second break, but I apologize for my late start. All right, today's lab deals with aromatic compounds. I better open it first. Uh-oh. Hold on one second. All right, does everybody see on your screen aromatic electrophilic substitution reaction or substitution lab? You see that on your screen right now? Give me a thumbs up if you see it. Thank you. All right, now if we were in a lab, which we're not face-to-face, I would be warning you today, we're going to use concentrated sulfuric and concentrated nitric acid. These are very dangerous chemicals. Wear gloves, and we provide them. And don't forget to have your safety goggles on, which we always do. Always go in what's called the acid waste bottle. And because this is so dangerous on your skin, throughout the lab, I tell you, don't touch your face or anything else while you're wearing gloves. Now, you learn, and again, this will never be on a test, but I can do it in a lab. Then when you do electrophilic aromatic substitution, you react something with a benzene ring, and you place one of the hydrogens on the benzene ring with whatever you're attaching. I called it E. What happens if there's something already on there? And in organic chemistry, I don't know why, but for this type of reaction, we call that group on the ring Z. And if you add something to the benzene ring with a group already on there, you can either put it on this position, which is the ortho, 1, 2, disubstituted, and you get the ortho product. You can also go on the 1, 3 position, and that's meta. And finally, it could go on 1, 4. And this would be para. Now, have you ever gone to a concert or something like a fair where like the DuPage County or Duquesne County does it, where they take an open field and make it into a parking lot? At least they used to. I haven't been to King County fairs in a long time because of the pandemic and other reasons. And you have those people telling you, no, park there, don't park here. And they don't like me because I don't listen to them. They're directing you where to get parked. Well, when there's something on a benzene ring, it's called the director. And if it sends it to the ortho position, it's called an ortho director. If it sends it to the meta, 1,3, what's coming in is a meta director. If it sends it to the 4 position, 1,4, it's a para director. Now, in this reaction, you're going to be reacting bromine on a benzene ring, bromobenzene, with nitric and sulfuric acid. And you'll be putting a nitro group on it. And you're going to find out, is bromine an ortho, meta, or para director? Now, there's something I need to talk about with directors. And take notes, this will help you. Now, the two types are ortho-para director or meta. And what determines this is whether Z is electron withdrawing or electron releasing. And that gets into something I teach in a 2 semester, but I won't get into what does it mean by electron withdrawing, electron releasing, but it helps determine what type. Now, if you notice ortho-para, you get either 1,2 disubstitute or 1,4. Now, listen carefully. Once in a while, if Z is real big, remember Z is the director that's on your benzene ring. If Z is big, it will sometimes block the ortho position. So you won't get ortho and para. Sometimes you only get para, but that's still called an ortho-para director. Again, when you have 1,2 and 1,4 products, when you have Z and into 1 on the 2 position or 4 position, you put in the group that's coming in, we call that an ortho-para director. But sometimes you may only get para because if Z is big, it will block the ortho position. If you get 1,3 disubstituted for your product, that's called the meta. And based on what you do, then the product you get today, you will determine whether bromine is an ortho-para or meta. Even if you only get para, it's still called an ortho-para director. Now, there's something else I need to teach you about. Why do we react nitric acid plus sulfuric acid in this reaction? Because the reaction you're going to be studying is if you take bromobenzene, react with nitric and sulfuric acid. Now I'm going to do something sneaky here. Dr. White can be sneaky. I'm not going to show you which isomer you get. I'm just going to show it like this, that somewhere on the ring, I'm going to put a nitro group. Well, why do you react nitric and sulfuric acid together? Well, let me write nitric acid this way, and sulfuric acid is a proton donor, which is what an acid is, and I'll write it this way. And these non-bonding electrons attract the H plus to form this intermediate. And this intermediate, you notice I have 2 hydrogens and an oxygen in this molecule. When you have a stable leaving group, and trust me, water is a stable compound. This means it loses water and forms the nitronium ion. Actually, it's a cation, but I call it an ion, nitronium ion. And this is the group that attacks the benzene ring to put a nitro group on it. So why do we react nitric and sulfuric acid? To form the nitronium ion. Now, this is a really exciting reaction to do in the lab. And also, this is one of those where Dr. White is at my highest level of alert, because both nitric and sulfuric acid concentrated are very dangerous chemicals. And in fact, even at COD, they no longer use this, they substitute another acids. I don't even think they do this reaction anymore because it was so dangerous. But let's look at the lab. So what you'll be doing is to heat this, you have to heat this. You take a beaker and put DI water and boiling chips. Now, why do you use boiling chips when you heat something in a glass on a hot plate, or if you were ever in the kitchen, which you won't? And that's because of the following. When you boil something, and you can see Dr. White will never be an artist. My mother was an amateur one. If you put water in glass, glass is smooth compared to the metal pots and pans you have at home. And when you boil something, boiling is when the vapor pressure of a liquid, that's the gas formed when you heat the liquid, is equal to the atmospheric pressure. So what you form are bubbles. And because glass is smooth, there's no rough surfaces for these bubbles to form. And you get these big bubbles. We call that bumping. I'll talk more about this. So you put in these rough little stones called boiling chips. Which provide a rough surface in glass for the bubbles to form, so you don't get big bubbles, which is called bumping, so that all doesn't come splashing out at you. If you ever use a microwave and you put in something like in a glass measuring, I always put a piece of rice in there so it doesn't bump. Otherwise, you can get splashed with very hot or boiling water. Now, what you'll do is in the round bottom flask, you'd add 3 milliliters of concentrated sulfuric acid using a funnel. Then you cool that in an ice bath, and I get you starting the hot water first because it takes a while for it to start boiling. And then you will add, after about 5 minutes in an ice bath, ice and water, you will add through a clean funnel in 3 different parts, 3 milliliters of nitric acid in drop-wise, 3 different ways slowly. And you'll swirl the whole thing every once in a while. You keep it in the ice bath, you'll add 1.6 milliliters of bromobenzene in 1 portion, let it sit for a minute, swirl it, take it out, let it come to room temperature, about 5-10 minutes, then you put it into boiling water for 25 minutes. Now, there's a side reaction. I haven't talked about side reactions. Sometimes you have impurities in compounds you mix together, do chemical reactions. Now in the lecture, I don't talk about this, but in real life, you have to worry about it. And if you do this reaction in the lab or in the hood, you'll see once in a while, most of the time, this brown gas coming out of there. And the brown I should have here, gas, that you might see as a poison, but you're in a hood and this takes air out from above the reaction and takes it all the way up because the fans we have on top of the roof onto the roof, and it dilutes it in the air above, and there's nobody that should be on the roof. Whenever I run this, we check with maintenance to make sure there's nobody working on anything on our roof. And you that will happen. Now let's come up here.
Replace your notebooks and printed documents with Remarkable 2, the only tablet.
And you can watch this whole video on yourself. I'm just going to get to the fun part. Oh, I picked the wrong one. This one they don't heat. Hang in there 1 second. Sorry about that. Now here they have it heated up like this right on a hot plate. We do it in boiling water. Then if we had time, we'd separate this is solid you make. We don't, so I just have you show me the solid. And if we had time, which we only have an hour and 50 minutes for the lab, I'd ask you to show me the solid once it cools down. And then I come around and if we had time, I would ask, I asked you, did you get a solid form? And I initial it. This is a K inside of a W. And it's my initials. And the melting point would be 121 to 123. This is what students would get when we teach. We used to teach this at COD where I have more time. They get this. Now, here's what you have to do. In table 1, I have relevant melting points. And here's the literature value for ortho, meta, and bromo, ortho, meta, and para, bromonitrobenzene. Now, remember about the colligative effect. Sometimes if you have impurities, your melting point might be lower. And also if you haven't done 1,000 melting points like I have, maybe not 1,000, but I know over 500 in my lifetime, you're going to get a little lower being a student who's still a rookie. Now, your product would be one of these based on the melting point. And you have to right here, write in what you think which bromonitrobenzene you got. And then here are the lab questions right here that you have to answer. And if you've been following along, you can always go back and look at the YouTube video in case you weren't. This will help you answer these questions. With that, I'm done. I went a little over because I started late. I apologize. We're still on good track. Again, I apologize. This happened twice now in the last 15, 20 years. This is the second time. Hopefully that'll be the last. With that, I'll say, gang gesund. I'll see you next Monday. I'll have my office hour if you have any questions. One of you I asked to talk to me after class today, so stick around. And with that, I'll say, gang gesund. Goodbye.